hope you've all had a nice break, and we're back for the last session of the workshop, and we have our last, but by no means least speaker, who's you've already been introduced to because she sat on our careers panel and has already explained that she's had a mixed and varied career, and so I'd like to introduce Emine Yilmaz. My pronunciation is never great, and who will be discussing large language models for evaluation. Okay, thank you.
Thank you. Thanks everyone for staying until the last talk of today. So I'll be talking about using large language models for evaluation, in particular trying to focus on opportunities, particularly on limitations, actually. Before I start, I would like to briefly talk about why evaluation is so important. Why did I pick to talk about evaluation? Because I feel that lots of researchers just think that evaluation is something that happens on the side. Okay, we get some data and it's not the main topic. It's not at the core of model development. So we try to just gather some annotations and evaluate. But evaluation is extremely critical for model development, actually. So just a quote from Lord Kelvin. He said, what you can't improve, you can't measure, you can't improve. And that's exactly why evaluation is so important, actually. When we develop models, any model, LLM-based, any model really, if you don't have proper evaluation mechanisms, then you won't know what is a better model. So you may end up just building something that is not really aligned with actual real user satisfaction. And especially in traditional model development cycle, evaluation metrics tend to serve as objectives models are optimized for. So if we have a bad metric, we will end up building a bad model, basically. Which is why evaluation is really a key research challenge that lots of researchers have been working on for years and years, to be honest, and it's still an unsolved problem, both in terms of how to obtain annotations and also in terms of what metrics should we use in optimization for various tasks. So again, why is evaluation so important? Poor evaluation can lead to, first, of course, optimizing for the wrong metric, which could result in suboptimal performance. It could lead to misinformation if we don't evaluate misinformation, if we don't have a way of evaluating misinformation, for instance. Biased or harmful outputs, safety risks, and so on. So we really need evaluation mechanisms that capture many different aspects, ideally. And these are critical, of course, in all development tasks, all model development tasks, but particularly critical for domains such as healthcare, for instance, law, education, and things like that. But it's important regardless of the domain that we are focusing on. What I'm seeing, again, in lots of researchers, early researchers, but as well as established researchers, is that importance of evaluation is often ignored, and which leads to really suboptimal model development, suboptimal performance. The general trend is, okay, let's gather some annotations. You could use an LLM, you could use a human annotation. Let's get them. Let's try to evaluate. Oh, okay, we did get a good performance based on what we have, and then great, let's ship it. That's kind of part of the tendency, not for everyone, but there is a tendency towards that. And one of the primary things that evaluation is sitting on is, of course, annotations. Some sort of annotation is necessary for most metrics. Like, for instance, in NLP, we use Rouge, Blue score. They require reference, having a reference like a gold response, for instance. Or lately, we have been using qualitative metrics such as relevance, factual correctness, coherence, and so on. These dimensions that cannot be quantified with a numerical score, that they also require some sort of annotation. Traditionally, we have been using human annotations. They can come from experts or crowdsourcing. But human annotation is, of course, expensive and time-consuming. And human annotations actually have been kind of a bottleneck in model development for many different years. Expert annotators require extensive training and guidelines. Crowd annotations may not have as good quality. And in general, because of the time and expense it takes to gather these annotations, it was a major bottleneck for model development. More recently, as a lot of you know, we have been using LLMs as judges instead of human annotators. They have shown great potential, and when LLMs were introduced as judges, lots of researchers were extremely excited, and a lot of people thought, yes, we finally found the problem to this data annotation, solution to the data annotation problem that we have been facing. Finally, we have LLMs that can give us scalable data, like that they can evaluate thousands of outputs very quickly. They are quite flexible in the sense that we don't need to train judges, for instance, especially for expert judges, you need extensive training, which might take a lot of time. We can just give an LLM new instructions, new judging instructions. They can do the judgment right away. They don't get tired ever. They don't have to go back home or sleep. We can get lots of data, and they are not also subject to human subjectivity, because even different humans were shown, or different annotators were shown to give different ratings if you ask the same annotator for a rating at different times, for instance. And they can, of course, be much cheaper than using humans. So when LLMs were introduced, people were very excited. And one of the primary advantages, of course, of using LLMs as judges is that they enable automated dynamic benchmarking, in the sense that until recently we have been working with static benchmarks, where we would have fixed data sets, for instance. Because they are so flexible and they can scale very quickly, through LLMs, we were able to very quickly and in a dynamic way adapt our benchmarks. So this was great. Lots of researchers were very excited and said, okay, great, we can now replace everything with using LLMs. We don't need human annotations at all. So recent researchers, in fact, did show that using LLMs as judges result in great performance if you compare these annotations obtained from LLMs with human annotations. For instance, for relevance assessment task, they were shown to result in similar performance to expert annotations, for instance. And if you were to compare the performance of LLMs as judges to crowd workers, they were shown to even perform better than crowd judges, actually. Then the question is, are LLMs really capable of truly replacing human judges? And for a while, lots of researchers thought, yes, we are done, like we don't need human annotations. But there are lots of limitations associated with using LLM as a judge that we hadn't explored. And recently, there are more and more findings about some of these limitations about using large language models as judges. And in this talk, I would like to briefly talk about what are these limitations that we should be cautious about when using LLMs as judges, and how we can overcome some of these limitations. I'm not saying solve, but possibly improve or overcome some of them. So what are possible limitations of using LLM as a judge? One is quality of judgments. On aggregate, you may see high correlation with human annotations, but if you look deep down, you might see some quality issues, which I'll tell you in a bit. And there is another issue that I think it will be interesting to this audience is that they need significant improvement for multimodal tasks, actually. And there have been some recent findings about this, and I'll give you some examples of this. And judgments obtained by using LLMs are also susceptible to bias. That's another issue that I'll discuss in a bit what I mean by bias. And finally, this bias that may be present in LLM-based annotations could also lead to biased evaluation results. And that could lead to us selecting or optimizing for the wrong thing, or optimizing for the bias itself, and which could make the bias issue worse and worse over time. So let's get into details of this as to what type of limitations exist and what do I mean by these limitations. First is the issue with quality. So here you see a plot. This is some of our recent work where we looked at some of these possible issues in LLM-based annotations, where our analysis showed that LLMs tend to assign higher scores to bad responses, actually. Yes, on aggregate, maybe you have high correlation, but if you deep down with human annotations, but if you go deeper, what you will see is human annotators tend to apply much stricter criteria than LLM-based annotators. And this is quite important, actually, because what this means is you can have two systems, one system returning really bad results, whereas another system that returns reasonably good results. If you were to use an LLM as a judge, you would incorrectly think these systems are of similar quality. So what it does is it actually causes evaluations to have less discriminative power. That's one issue. Here you see a plot of this, where x-axis here is the relevance label assigned to each response by a human, that's the blue-purple one, and by GPT-4, when using GPT-4 as a judge, that's the orange one. And you can see that GPT-4 is a lot more likely to assign a relevance grade. This is a relevance annotation task. Relevance grade that is greater than or equal to 1 as opposed to 0. And this is just one example. This seems consistent for different LLMs as well. And I've recently seen other publications which show that this pattern is observed by other researchers as well. So that is one issue. And another issue when using LLMs, associated with LLMs as judge in terms of quality, is that most LLMs are susceptible to judging non-relevant sentences or documents or responses, for instance, as relevant if query words are randomly inserted at random positions. So you can easily trick, and an AI model, especially lately, these models are quite intelligent. They could learn just to generate a response that is possibly even not meaningful, but just inject random query words and trick the LLM to annotate it as great. And then you could just optimize for this, and this issue could get even worse. So that's one issue, quality, and we have to be really careful about this. Now, for multimodal tasks, it's a topic which requires significant attention, actually. As some of you know, multimodal large language models demonstrate they have shown remarkable performance on certain tasks, but their performance is limited, especially on tasks where the focus is on direct scoring or direct ranking. So let me explain by what I mean. This is a paper where they focused on looking at using the quality of using LLM as a judge on an image-to-text task. So you have an image, and the task is to convert it to some text, like the text that describes the image, that answers a question about the image, and so on, for instance. And they looked at three evaluation setups, where one is you would compare the two outputs, and the LLM as a judge is asked to decide which output is better, so pairwise comparison. The other one is direct scoring. Which output is this? What is the rating for this output? For instance, is this non-relevant? Is this highly relevant? And so on. So just give a scoring to a particular response. And the third one is to generate a ranking for the response and to evaluate the ranking that is generated. So a batch ranking task. And what these researchers have shown is that when using LLM as a judge, on pair comparison, you could do reasonably well, like 79% agreement with human annotations. But on scoring and batch ranking tasks, the agreement is lower, actually. And for ranking, it's much lower. And this is for image-to-text tasks. So still, the setup is kind of limited to these two modalities, in a sense, in the input and output. If you go to any modality, where the input can be from any modality, and the output can also be any modality as well, which is much more general, the issue becomes even worse, actually. So this is another paper where researchers looked at two setups. One is multimodal understanding, where the input could be any modality and the output has to be text, so to see if the model is able to understand, for instance, this image, this audio, this video, and so on. Or a generation task where the input could be from any modality, the output can also be from any modality, so much more complex. And what they found is that, first, as kind of expected, models tend to perform much better in multimodal understanding, where input can be from any modality and output is text, compared to multimodal generation, where both input and output can be of any modality. And this makes sense, but if you look at the numbers, for instance, what they observed is that for pairwise comparison, on pair comparison task, for instance, on MMU, multimodal understanding task, the agreement with human annotations is like 66.5%. Whereas on score evaluation, if you ask an LLM to directly score the response generated, the output, the agreement with humans is much less. It's like 42.79%. And if you look at multimodal generation task, this agreement becomes much less. It's like 50% on pair comparison. Even on pair comparison, it's quite low. On score evaluation, it's like 30%. This is extremely low agreement, actually. And again, you see that we say the same pattern here. Models tend to perform much better on pairwise comparison compared to scoring an individual item. But overall, the performance of these models on any modality task, when the input is from any modality, even when the output is just text, even then, the performance of these models is quite low. So what this is showing is for multimodal, especially any-to-any modality or any-to-text modalities, we definitely need significant more research when using LLM as a judge. For pairwise comparison, maybe it's okay, but again, still, I don't think these agreement rates with humans are that promising, actually. So when you use LLM as judges for multimodal tasks, best is to use, if you can, to use them in a pairwise setting, pairwise comparison setting. But even then, it is best to monitor their performance with human annotations. And that's one call, actually, to the community. I think we definitely need further research when using LLM as a judge in a multimodal context. Another limitation of using LLM as a judge in general is the possible bias in judgments. Now this is, again, an issue that few researchers have recently started thinking about. But as you know, LLMs in general tend to be trained on similar type of data. They have similar type of architectures. We may have different LLMs, but at the core, they have similar architectures and similar objectives, more or less. And what currently lots of researchers are doing is we have one LLM-based model generating a response, and then they might use another LLM to judge the response generated. And because these two models tend to come from similar model families, let's say, and are trained on similar objectives, on similar data sets, what might happen is that this LLM that is used as judge may incorrectly give a very high rating to the response generated by an LLM. And this type of bias could become even worse if identical models are used. For instance, if you use a GPT-based model to generate the response and another GPT model to actually do the judging, then it might think that, oh, GPT is doing perfect, whereas it might even say, like, another model is doing slightly worse, possibly. I'll explain, I'll show you with some examples here. So that is an issue when using LLM as a judge. We have to be very careful about the possible biases we might see and we might kind of cause when using LLM as a judge. And another bias that researchers have observed is the length bias. So LLMs tend to be trained on texts that are quite long and more like writing type text, for instance, Wikipedia articles. And because of that, they are not really trained on spoken language in a sense. Because of that, LLMs tend to favor responses that are more length-worthy, that are longer, and they are not really good at judging certain tasks, for instance, verbosity, or judging tasks where the expectation is to have a very concise and short response, ideally, like in a conversational setting, for instance, especially over voice. So on certain tasks, certain evaluation tasks, especially that require this type of conciseness, LLMs may not be the best methods to use for evaluation. And by the way, some of this research was originally based on when looking into textual data, but some of recent findings on looking at multimodal setup have shown the same issues with bias have also been observed when using LLMs as judges in multimodal evaluation as well. I just want to give you an example about what I mean by this bias, just with real data. So these are some plots that we recently generated based on some data from a challenge that we co-organized. So this is a challenge where our goal was to invite researchers, different researchers, to give us their annotations so we could evaluate which LLM, which method is doing better, for instance, than the other, where we had gold annotations obtained by National Institute of Standards and Technology. So this is based on some track, like a challenge that we organized that was supported by NIST, National Institute of Standards and Technology. And each dot here corresponds to a system that was submitted from different researchers from all around the world to our challenge. This was actually a passage ranking task, by the way. And what we did is on the x-axis, we have these human labels. These are expert annotators from NIST, very well trained. They have been doing annotations for years. And y-axis is our evaluation results when we use GPT-4 labels, when we use GPT-4 for evaluation. And on the left, we have one evaluation metric, NDCJ at 10, which is commonly used ranking metric, which focuses on the top quality of top 10 results retrieved. And on the right-hand side, we have another metric, mean average precision. What you can see is common across the two, and we have the line y equals x along the diagonal, just so you can compare the bias, the effect of how much off we are from line y equals x. In both plots, one thing you can see is that when we use, for instance, GPT-4 to do the annotation, we are significantly overestimating the performance of LLM-based models. By the way, the models that are submitted, we categorize them into 4 different categories: GPT-based models, GPT plus T5, these are combinations, models that use combinations of both, T5-based models, and other models, like other LLMs possibly, or maybe 1 or 2 traditional as well. One thing, again, you can see, because most of them are LLM-based models, when you use an LLM to do the judging, you are significantly overestimating the performance of these methods. And another thing you can see is, if you look at the performance of GPT-based models, that overestimation is even higher for GPT-based models. The red crosses there, GPT model families, they are kind of slightly higher from the diagonal, slightly further away from the diagonal. Because we are using a GPT-based model to evaluate, to do the annotation, we are seeing that they are significantly overestimating the performance of GPT-based models as well. Another analysis that we did is we wanted to take a look, what is this kind of this discrepancy? Why do we see this difference from the diagonal? Is it really that there is some bias because of the type of judging that we have, because of using GPT-based labels in evaluation, for instance? So we developed a linear mixed effects model to assess differences in metric scores when using evaluations obtained using human judges as a reference. So compared to evaluation results we would have obtained if we were to use human annotations, what are the factors that cause divergence from these evaluation results if we were to use an LLM, for instance? So we looked at different factors, such as whether it was judged by GPT-4, for instance, system type, is it a system based on GPT? Is it a system based on T5? Is it a system based on a combination of T5 and GPT, for instance? And we also took a look at other factors that might cause some bias in LLM-based evaluations, such as query difficulty, for instance, because we expected that since LLMs tend to give higher ratings to non-relevant items, for instance, for difficult queries even, they may give much higher scores than humans. Number of words in the query, QW there, for instance. Document length, again, LLMs tend to prefer verbose documents, for instance, and things like that, a few such factors. We also looked at interaction effects between the different factors. For instance, is this a GPT-type system that was judged by GPT-4? Or if system, is it a T5-based system that was judged by GPT-4, and things like that. What our results showed is that the factors that play a significant role in divergence from human-based evaluations are whether we use an LLM for evaluation, so that is a reason, basically. System type, GPT, as expected, a GPT-4-based annotator, LLM, it looks like it is giving much higher preference to GPT-based models, or system type GPT plus T5. Query difficulty, again, LLMs do not distinguish much between relevant and non-relevant results, possibly. Document length is another thing. We did see, like even in this mixed effect models that we ran, That was a significant factor for the divergence from real, actual evaluation results, and interaction effects between these factors. So what does this mean for system development? What this could mean is, of course, we could possibly deploy bad systems. That's what it means, just because they use the same model as the one that is used in the judging process, for instance, or just because they are based on LLMs. Basically, one thing we could, for instance, there is this current belief that LLMs tend to be much better in everything. But one possible reason for that could be we are using LLM-based evaluators, which exhibit this bias. And that's the reason maybe we are thinking that some traditional approach, maybe even a smaller BERT-based model, is not doing as good, even though it is. But we are using LLM as judges, which is favoring these LLM-based responses. Another issue that I think really is very important and a bit worrying, actually, is that results that get presented to users could get dominated with responses generated by AI or LLMs. What is happening is, as you know, the internet is becoming more and more dominated by AI-generated text or LLM-generated text. Imagine training your search engines by using LLMs as judges, which most people do. What these models will learn is that they should favor LLM-based texts that were generated. So they will learn to retrieve these LLM-based texts that was written by LLMs as opposed to human-generated text towards the top end of the ranking, which means that, for instance, us, when we read the news, when we search Google or when we search Bing, the news or whatever text we observe will be dominated by LLM-generated text, for instance, as opposed to human-generated text. And of course, these are susceptible to certain biases, such as hallucinations. Some of them, it's very easy to generate text in a way that, for instance, they attract more human attention. For instance, they may contain some critical information that was intentionally put there, possibly, for instance, or they may exhibit certain biases, like, for instance, much more wordy, as I mentioned. A similar problem was actually is a topic, some of you might have heard of it, there is this recent research trend where researchers are working on model collapse, and some of my PhD students are looking onto this as well, where the idea is if we have, for instance, machine learning models, LLMs, as you know, we are continuously improving these models, and internet is becoming more and more populated with AI-generated text. Model collapse is when you train an LLM, which is an AI-based model, on text that was also AI-generated. And researchers working on a model collapse have shown that by training these models on AI-generated text, the type of biases that are exhibited in LLMs are getting worse and worse over time. And this type of bias in LLM-based judges is another factor that could make this model collapse issue even worse, actually, because our retrievers may become more and more dominated. Our results that we are seeing, they will be dominated more and more by AI-generated text in the future. So that's one topic that we have to be really careful about in the long run when using LLMs as judges. Now, the question is, how can we improve these limitations? One thing is, of course, we should always use LLMs, I think, in combination with human assessors. And we should definitely always have some human annotations, maybe in a small subset of data, but use that to monitor the performance of LLM as judges. But not only monitor the overall performance of LLMs, but try to look for possible biases in the judgments as well. So at the very beginning, researchers were just looking at, okay, on aggregate, the correlations look great, perfect, LLMs are perfect, but no. You have to go deeper. You have to look into these possible biases, because these biases over time will become worse and worse, and it's important to be aware of this, and it's important to track this. Another possible way to improve some of these issues is to utilize the power of multiple models to improve problems with quality and bias. So just very quickly, how can we do that? One way to do it is to use different prompts, for instance, or models, which could bring in different perspectives to evaluation. And these different perspectives could help to reduce the possible bias that exists. or they could also help reduce quality issues, because different models could bring in different know-how, for instance. That's one possible solution. And aggregating these different models could actually also help us utilize multiple smaller models, and instead of using a very large models, which can be very costly, and not all of us have access to these type of models, to improve, to use smaller models to further improve the overall performance. So this is just some very simple initial experiment we did a while ago, where we try to see if you were to combine different models, can we obtain better performance than using a much larger model as a judge? So we did two very simple experiments. One of them is we used one fixed LLM, large language model, and we used it with different prompts, where for the same evaluation task, we told the model to approach it differently. And if you are looking at, for instance, things like model robustness in large language models, you might know that by changing the input to the LLM or the prompt text, even very slightly, you can get very different outputs in LLM results. So that's one issue about robustness, which I didn't discuss in detail. But one thing that we thought about when we looked into this robustness issue is that we could use it to our advantage. We could give different instructions, different prompts, and then get different outputs, aggregate them together, and use them for evaluation. Or, of course, you can just use different models, ask them to generate labels, and aggregate them together to generate the final output score. Just very quickly, what our results showed is that on the top, we have the top performing baseline in terms of the very large models. And then as baseline, we also have a small fine-tuned model. And then we have the prompt blender, where we use one model with different prompts and blend or combine the output of these different models together. And finally, the last row shows LLM blender, where we have different LLMs and we aggregate results from these different LLMs and use the aggregated result for evaluation. What our results, very simple experiment, but what our results show is that by doing simple aggregation of different LLMs, you can obtain significantly better results than using a very large LLM, even though you may be using a much smaller LLM in terms of size. And even like using a very small model with different prompts, you can almost approach the performance of very large and sophisticated models. So that's one way that you could use to improve this quality and bias issue, possibly with LLMs. Another way where you could utilize the power of multiple models is through debating. Basically, the idea here is to ask multiple LLMs to debate with each other to reach a consensus on evaluation. Each LLM is assigned to support one side of an argument, and then you have a separate judge that is observing this debate and making the final decision based on this observation, which you can see here. And this debating task actually could result in significant improvements when using LLM as a judge. Of course, you still have to be very careful when you design your debating task, because since LLMs are not typically designed directly to debate, specifying the rules of the task very carefully is really important. So that's one thing I would like to emphasize. So you should make sure to ask the models to support a side, and ask that the arguments should be backed by logic, facts, and evidence, ideally, so that they don't just come up with random arguments. And the arguments should be convincing and concise, ideally. And even in this setup, by the way, you have to be careful, because this issue that I mentioned with bias could and is likely to come up, because imagine you have different debaters and you have the final judge. If the judge comes from the same model as one of the debaters, there is this tendency of the judge always picking the side of this one debater, and that was observed. So there is that issue you have to be careful about. So you have to make sure to either use completely homogeneous models, identical, with possibly different prompts or different sources of information used, or completely heterogeneous models. And, but overall, this is one way, another way that you could utilize the power of multiple models when using LLMs for evaluation. I know I'm running out of time, so just to conclude, what I wanted to focus on in this talk is actually kind of I wanted to focus on the attention on the importance of evaluation, and in particular on the challenges or limitations of using LLMs for evaluation, because LLMs being used for evaluation and annotation is becoming more and more common lately. And I see that lots of people just write down the prompt, just use them as is. They think LLM-based judges are magic without doing even any checks, like if their prompt works. But there are lots of possible limitations and issues that we have to be very careful about, such as issues associated with quality. In multimodal, we definitely need a lot more research on using LLMs as judges. Possible bias in judgments that could lead to possible bias in evaluation results that we observe. And finally, I briefly try to give an idea about how we could slightly improve some of these limitations by making sure to always have some human annotation and monitor LLM-based judgments on a small subset, and also to utilize power of multiple models in order to improve these issues with quality and bias in LLM-based evaluation. Thank you very much for staying for the last talk. I know it must be very tiring for you, so thanks.
Thank you very much for a really interesting talk. So have we any questions? Oh, there is one there. Can you keep your hand up while they find the microscope? Microphone, sorry.
Hi, I'm Sadat. First of all, thank you very much for the fascinating talk. My question is about whether prompt engineering could be a way to solve the annotation, the bias in the annotation when using LLMs. As you mentioned, different prompt techniques could lead to different outputs of the LLMs. So do you think prompt engineering could be a solution for these biases in the LLM annotations?
Mm-hmm. Prompt engineering could possibly help, actually, and in fact, this prompt blender, in a sense, by using different prompts, we are kind of doing a bit of that, possibly, but there are no guarantees, unfortunately, into that, because still, the model itself will have its own parametric knowledge, and even though you may be using different prompts, that possible bias inside the model itself, and the preference, the tendency of the model preferring the same LLM might and is likely to be still there. So you won't be able to solve it just by prompt engineering, I don't think. But it would improve so that the model has different perspectives. It is using different perspectives in evaluation. It would definitely help.
Thank you.
Okay.
Hi, thank you for the wonderful talk. I'm Hazrat. I'm a lecturer in Sterling University. So I do a little bit of prompting with the LLMs. So that was actually my question as well, that prompting, of course, can usually, like, it is observed that this is like the key factor. But in continuation to that, there is also this concept of prompt injection and jailbreaking. So I was wondering if you would also share some insights into that, because that is even if you are like using this as a judge, so the output can be easily manipulated. If I don't know what text, I guess you are using on the text from users, so they can actually kind of do jailbreaking by including hidden prompts, hidden messages into the prompt. So I was wondering if you can share some insights into.
Yeah, we haven't looked into those, but definitely these are some other issues. I agree. There are lots of ways you could hack, and in fact, there was some work on. I think in scientific publications, you might have seen it. Where
a recent incident where the authors basically put hidden messages, like in white fonts or small.
Exactly.
And they. This was discovered when they put it on the archive, and somehow so the human observer would not notice it, but it will affect the output of the LLM if the reviewer is using LLM as a reviewer.
Yeah. So it's an example, right? In a sense, like the reviewers are acting as judges, and if they use an LLM-based model, for instance, so it's very easy to trick them. I agree. I think it's a major problem that we have to be very careful about. And if you think about the capabilities of these models, they can easily learn. Like the humans don't have to even manually do it. The model itself may learn how to trick the evaluator.
Yeah, because it doesn't matter how good the system prompt is, somehow someone will break.
Yeah.
Another question, and I hope I'm not hijacking the time. So for the second suggestion, using multiple models, is it like a brute force approach? Because it might not be feasible for everyone to use multiple models because of the resources.
Yeah. That's the reason why in our experiments we actually focused on smaller public models. And indeed, like if you aim for like a large model, but the advantage is if you are using smaller models, it's much cheaper, publicly available, and when you merge them together, you still get a very, very good result at the end. And yeah, for very large models, it may not be feasible. And these issues may even, they are not just for academia, even in the industry, even if you have lots of resources, you may not have resource to use very large models and aggregate them just for this task. So, but our results, what they are showing is with smaller models, you can still achieve what you need.
Okay, thank you. I think there's one more at the back, and then, well, maybe I was seeing the gentleman. No, it was the gentleman further back I'd actually raised.
I feel bad. Sorry. No, I thought a really, really fascinating talk. I was just wondering, like, even when you have human judges, I'm imagining they also have conflicts of opinion. And it seems like almost like it's replicated in the LLM world. Is there any kind of inspiration from how we resolve conflicts between humans that might actually kind of help with some of these sort of challenges?
Yeah, there has been lots of research devoted to exactly tackling this issue. Like, for instance, because before LLMs, we would have humans, and how to make sure you get quality judgments from humans was something researchers try to look into. And exactly, for instance, some research look into humans debating with each other, like having them sit together, debate, and reach a final decision. But then they showed that may not be a very good idea for humans because they may influence each other, and at the end there might be a bit of bias, like to the strongly opinionated one. Again, that may still be an issue in LLM-based evaluation as well, actually. Like the one who is very good at convincing the final decision maker, the final judge, could be the one whose output is going through, and that was observed actually in this debating paper. I didn't mention it, but that is an issue. So similar type of things that arise indeed. And another thing in human-based evaluation, one approach to improve the quality was to use multiple annotators and then aggregate their results, which is this ensemble-based LLM approach that we are seeing. So yes, some of this work was observed in human. There are different type of issues, though. For instance, with humans, one type of bias that people observed is, for instance, if you ask a human annotate a very good example, like a perfectly relevant example, and after that you give them a slightly less good example, their output would be biased because they would be impacted by what they have just judged. And for LLMs, because you are doing independent evaluation in a sense for each example, if that's the way you are running it, of course, that problem may not arise as well. So there are some common issues and there are some distinct issues between the two approaches of evaluation as well.
Okay, thank you. I think just to keep to time, we'll thank the speaker again. It was really interesting talk. Thank you.
Thank you.